Software testing is the process of evaluating a software system or application to identify any defects, errors, or bugs that may affect its functionality or performance. It is an important part of the software development life cycle, as it helps to ensure that the software meets its requirements, functions as expected, and provides a good user experience. Software testing involves various techniques and methods, such as manual testing, automated testing, unit testing, integration testing, system testing, and acceptance testing. Testing can be conducted at various stages of the software development process, including during development, before release, and after deployment. The primary goal of software testing is to ensure that the software is of high quality and meets the needs of its users. By detecting and fixing defects early in the development process, software testing helps to reduce the cost and risk associated with software development, and ultimately leads to a better end product. Manual testing is a type of software testing that involves human intervention to execute test cases, observe and analyze the results, and identify defects or issues in the software application. It is a traditional method of software testing that is performed manually, without the use of any automated tools or scripts. Manual testing is typically performed in the early stages of software development, such as during the requirements analysis and design phases, as well as during unit and integration testing. Manual testing is often used to verify the functional and non-functional requirements of the software application, such as usability, accessibility, performance, and security. Manual testing requires a skilled testing team that has a deep understanding of the software application and its intended use, as well as the ability to design and execute test cases effectively. Manual testing involves a wide range of testing techniques, such as exploratory testing, ad hoc testing, regression testing, and user acceptance testing. The main advantages of manual testing include human intuition and creativity. Manual testing allows testers to use their intuition and creativity to identify potential defects and issues in the software application that may be missed by automated testing tools. Flexibility. Manual testing can be adapted to changing requirements and environments, making it ideal for testing in agile development methodologies. Cost-effective. Manual testing is generally more cost-effective than automated testing, particularly for small-scale projects and early development stages. However, manual testing also has some limitations, including time-consuming. Manual testing can be time-consuming, particularly for large-scale and complex software applications. Limited scalability. Manual testing can become difficult to manage and scale as the size of the software application increases. Human error. Manual testing is susceptible to human error, particularly during repetitive and monotonous testing tasks. Overall, manual testing remains an important part of software testing, particularly for small-scale projects and early development stages, and can be an effective complement to automated testing. Automated testing is a process of using software tools and scripts to perform tests on a software application or system. The purpose of automated testing is to quickly and efficiently execute tests that would otherwise be time-consuming, repetitive, or impossible to perform manually. Automated testing can be used for various types of software testing, such as unit testing, integration testing, functional testing, regression testing, and performance testing. It involves creating scripts or test cases that simulate user actions and test the software under different conditions and scenarios. One of the benefits of automated testing is that it is faster and more reliable than manual testing. Automated tests can be run repeatedly, and they can detect issues and defects quickly, making it easier to identify and fix problems early in the development process. Another benefit of automated testing is that it can reduce the overall cost of software testing. Although there is an initial investment in creating the automation scripts, automated testing can save time and resources in the long run by reducing the need for manual testing and allowing testers to focus on more complex and critical testing tasks. Overall, Automated testing is a critical component of modern software development, as it helps to ensure that software is high quality, reliable, and efficient. Unit testing is a type of software testing that focuses on testing individual units or components of a software application in isolation from the rest of the system. The goal of unit testing is to ensure that each unit of code functions correctly on its own before integrating it into the larger system. A unit can be defined as the smallest testable part of an application, such as a function, method, or class. In unit testing, each unit is tested in isolation using automated testing tools to ensure that it performs its intended function and returns the expected result. Unit testing is typically performed by developers as part of their development process. It is usually automated, with the help of testing frameworks and tools. To save time and effort, unit testing has several benefits, including early detection of defects. Unit testing can detect defects early in the development cycle, making it easier and less expensive to fix them. Improved code quality. Unit testing encourages developers to write better and more reliable code, leading to higher quality software. Faster debugging. Unit testing can help developers quickly locate the source of defects in their code, making it easier to debug and fix issues. Better maintainability. Unit tests provide a safety net for developers when making changes to the codebase, ensuring that changes do not break existing functionality. Overall, unit testing is an important part of modern software development and can help ensure that software is reliable, maintainable, and of high quality. Integration testing is a type of software testing that focuses on testing how different units or components of a software application work together and interact with each other. The goal of integration testing is to detect any issues or defects that may arise as a result of integrating the different units of code into a complete system. Integration testing can take different forms, depending on the type of software being developed and the integration points that need to be tested. It may involve testing individual units in pairs or in groups, or testing the entire system as a whole. Integration testing can be done manually or automated, and it can be performed at various stages of the development process. The main objectives of integration testing are to ensure that the individual units of code work correctly when integrated into a complete system, verify that the interactions between different units of code are functioning as intended, detect and diagnose any defects or issues that may arise as a result of integrating different units of code. Integration testing is an important step in the software development process because it helps to ensure that the software application meets its requirements and functions as intended. It can also help to reduce the risk of errors and defects in the final product, as well as identify potential issues early in the development process when they are easier and less expensive to fix. System testing is a type of software testing that focuses on testing the complete and integrated system to verify that it meets its requirements and is functioning as intended. The purpose of system testing is to ensure that the software application as a whole works correctly and meets the business and user requirements. System testing is typically conducted after integration testing and before the software is released to production. It involves testing the system as a whole, including all of its components, interfaces, and interactions, to identify defects or errors that may have been missed during unit or integration testing. The main objectives of system testing are to verify that the entire system meets the specified requirements and works as intended, identify any defects, errors, or inconsistencies in the system and document them for further investigation and resolution, validate that the system is usable, reliable, and secure in the production environment, ensure that the system can handle expected loads and operate within specified performance criteria. System testing can involve various types of testing, such as functional testing, performance testing, security testing, and usability testing, depending on the requirements of the system and the needs of the users. Overall, system testing is an essential part of software development, as it helps to ensure that the software application meets the requirements of the stakeholders and functions correctly in the production environment. It is a critical step in delivering high-quality software that meets the needs of its users. Acceptance testing is a type of software testing that focuses on determining whether a software application meets the user requirements and is fit for its intended purpose. The purpose of acceptance testing is to ensure that the software application is acceptable to the stakeholders, including the business users, customers, and other interested parties. Acceptance testing is typically performed after system testing and before the software is released to production. It involves testing the software application in a production-like environment to ensure that it meets the user requirements and functions as expected. The main objectives of acceptance testing are to verify that the software application meets the user requirements and functions as expected, ensure that the software application is acceptable to the stakeholders and meets their needs, identify any defects or errors in the software application that may have been missed during earlier testing stages. Acceptance testing can take different forms, depending on the type of software application being developed and the requirements of the stakeholders. It may involve user acceptance testing, UAT, where the business users test the software application, or it may be performed by independent testers or a dedicated testing team. Overall, acceptance testing is an important part of software development, as it helps to ensure that the software application meets the needs of its stakeholders and is fit for its intended purpose. It is a critical step in delivering high-quality software that meets the requirements of its users. Software testing tools. There are many software testing tools available on the market that can be used to automate various aspects of software testing. These tools can help to improve the efficiency and effectiveness of software testing, reduce the risk of defects, and increase the quality of software applications. Here are some common types of software testing tools. Test management tools. These tools are used to manage and organize the testing process, including planning, executing, and tracking tests. Examples include Jira, HPALM, and TestRail. Test automation tools. These tools are used to automate the testing process, including the creation, execution, and maintenance of automated tests. Examples include Selenium, Appium, and Test Complete. Performance testing tools. These tools are used to test the performance, scalability, and reliability of software applications. Examples include Apache JMeter, LoadRunner, and Gatling. Security testing tools. These tools are used to test the security of software applications, including vulnerability scanning, penetration testing, and threat modeling. Examples include OWASP-Zap, Nessus, and Burp Suite. Code analysis tools. These tools are used to analyze the code of software applications to identify defects, security vulnerabilities, and performance issues. Examples include SonarQuery, Checkmarx, and Veracode. Continuous integration and delivery, CI/CD, tools. These tools are used to automate the build, testing, and deployment of software applications. Examples include Jenkins, Travis CI, and Circle CI. These are just a few examples of the many software testing tools available. The choice of testing tools depends on the specific requirements of the software application, the type of testing being performed, and the preferences of the testing team.